Afternoon, everybody. My name is Wayne Ariola. I hope everyone can find a seat. To the virtual audience out there, welcome. I'm playing to the virtual audience today, so I need you to participate. So unlike most conferences, everyone's telling you to put your cell phone away. For the people in the audience and for our virtual watchers, could everyone take their cell phone out? Okay, so I'm going to ask you a question here. In a single word, what is the greatest barrier to software quality? And what you're going to do is you're going to text it to 22333, okay, in the to field. And then what you have to do is you have to type in the number 797832, then hit a space, and then enter your response. So I'm going to do it right now. And we'll wait a few seconds. So 22333 is the address. And then type in 797832 and a space. And then in a single word, enter in what's the greatest barrier to software quality. And we'll shift from this mode of observation into this mode of, hopefully I have control. We'll see the results in a second. So I'm on a split screen. I'm trying to bounce between the two. It's harder than it looks. There we should see. Okay. We're getting a lot of responses here. This is great. So automation, this is a word cloud that's being built. So automation is populated there. Environments, I think I fed that one in because that's what the talk's about. Results are starting to come in here. So still, we've got about another minute here. So text your message to 22333. In the text field, enter 797832, and in a single word, enter in what is the greatest barrier to software quality. So automation is winning for sure. And then we're getting a lot of here, management, tests, data. That's also another interesting one. Another management, so we got two managements, MGMT and management, poor management, criteria, defects, expectations. Expectations is a good one. Ambiguity, that's a huge one. Unrealistic, acceptance testing, adequate. So it looks like we kind of balanced out about 15 respondents. By the way, for the people who are watching this online for future views, this word cloud will remain live for the next. Ooh, someone went wild with environments here and automation. Stop pumping it in. That's one or two individuals, I swear. This will remain live for the duration until we turn it off. So it's going to be an interesting word cloud that will build, and we can publish these results automatically to the Parasoft Twitter feed. So you'll see this word cloud start to bloom. So today we heard at the keynote with Teresa Lanowitz that we're in this balance around time, scope, quality. She had a little bit different accesses. But it's really the same concept here. And now what's going on is we're in this era, and I like to call it an era of acceleration. So as software is the interface to the business, basically differentiable software releases is the way for companies to realize growth. So people want things faster, better, and essentially to meet the business demands. And you really have to balance this now. So I'm sure we've all heard of continuous integration. Obviously, continuous testing is a buzzword these days. Continuous delivery, continuous release. Continuous everything is the buzzword because we're in this era of software acceleration. And given that, I think, in my humble opinion, that this is the single greatest time in history to be a software tester. We're in an era in which software is truly transitioning from a process enabler into this era of being a business differentiator. And with that being said, QA, testers, and developers are really the people who are making sure that the business process or that differentiable business program is really the quality of that application needs to be top notch. And if you look at this, and this was another survey that was done over the years, and if you look at the concept of brand and brand loyalty, 88% of respondents said that quality drives brand loyalty, which really now starts to make us shift, that we have to really reevaluate this concept of cost of quality. And just to remind you, cost of quality isn't the cost of the software, the cost of the people, the cost of the environments that you need to test. Cost of quality is really associated with failure. What's the cost of that application failing? So over the Christmas break, because I had nothing really better to do, is I did a series of analysis. So I took all the major public companies and the software failures that were announced. So I don't know about you guys, who gets the CNN news feeds? What's remarkable is on the CNN news feeds, more and more the headlines around that come onto that news feed is around software companies and software failures. If there's an airline outage, if there's a security breach, if there's something associated with a software failure, it gets into the CNN headline news and it pops up on my phone. So I took all these public events and I basically tracked the decline in market value of these organizations once that announcement was made. So on the single day announcement, on average, companies lost an average of $2.3 billion of market value. This equates to about 3.75% loss of equity for its shareholders on the announcement of the software failure. So if you went back to your testers or your developers and said, hey, by the way, you're going to release this software? And they said yes. Are you guys ready to release the software? They say yes. You should ask them, are you prepared for potentially a negative $2.3 billion loss of equity with your software release? It changes the mindset. We have to protect shareholder value, and that shareholder value today is highly connected with the quality of applications. So another piece of data that I aggregated here was the market doesn't forget. And so it's what you see here on the screen here is the news articles. So what I did is I tracked the number of news articles associated with the failure. And this was interesting here because I tracked the articles for the first incident of failure versus the second incident of failure. And it goes to show you that some industries are more sensitive than others. So people love to bag on the airline industry, no matter what. Look at the airline industry, which is the second row here. On the first incident of a software failure, on average, there were about 1 million news articles published about that software incident. On the second incident, there was 5.5 million news articles published about that incident. So people are very sensitive about airlines, which I was shocked if you look at the bank. On an announcement of a bank software failure, there was about 451,000 news articles, but on the second incident, 650,000 incidents. I would think that the banks would be a lot more sensitive to the airlines, but I guess we just want to get where we want to go. Software companies, a little bit more sensitive here, where you have 1.4 million or 3.4 news articles associated with the second event. It just goes to show you that the market doesn't forget. So if you are trending in the wrong direction, it's time to turn it around now. I want to do a little case study here in terms of cost of quality and using Sony as an example. Sony, let's just say, had a number of different incidences associated with not only software quality, but they also had a couple of business problems associated with what they were doing. They had 2 particular incidences that happened almost back to back, which makes it a great case study for the cost of quality. The first one was a security breach, and the second one was their online gaming infrastructure went down. So this is looking at the market value of the stock. On the first event, which was stolen data, security breach, on the day of the event, Sony lost 19% of its market value. That is insane. I mean, 20%, about 20% of its market value out the door based on a failure. After 15 days, it rebounded about 8 points, got to 11, and it came back another point after 30 days to about a negative 12%. So the interesting thing here was the precipitous decline associated with market value all occurred around that one incident. Now, Sony unfortunately had a second event. The second event was that the online gaming platform went down, and it was down for a long time. So On that event, there was a negative 22% drop in market value. And then since it didn't come back up after 15 days, it dipped another 11% to a negative 33% market value. It rose just a little bit and recovered about 30%. Overall, the cumulative loss here was $18 billion. It seems almost unrealistic, yet you got to consider this is the cost of quality. I'm sure if you went back to that CEO who happened to lose his job, or the developers who were involved on the platform and said, hey, by the way, this release is going to cost the company $18 billion. Do you want to take a little more time to test? I think they'd say yes. I mean, it seems like a reasonable trade-off. Now, the interesting part, though, about our industry and the way we've been acting is we haven't really shifted the way we're doing business or the way we're testing. We still have very late-stage discovery associated with the defects in our programs. Very popular these days is really this concept of shift left. And what shift left means, and there's a number of different definitions floating out there, but for us in the testing space, it means open up the environment where you can do much more a lot earlier in the process. This is really, really reasonable thinking, meaning that if I can actually test earlier, if I can test when things are a little bit lower cost, if I can get some of those big block tests out of the way, we should do it, okay? But let me also give you a warning. Shifting left is not nirvana. So if you look at this curve, you're shifting left and you're doing defect discovery earlier in the cycle, but you're also doing defect discovery right over the time where developers are rolling new features. So if you look at this somewhat linearly, you run into a conflict of potentially bombarding development with fixes at the same time they're trying to roll new code. So shifting left is great, but you got to be careful around the process components of it. And shifting left just isn't enough. We not only need to shift left, we also need to compress. We need technologies in place where we can actually prevent defects from entering into the software development lifecycle in the first place. And our overall goal as testers should be to enable this process where we're lowering the surface area of that curve, where we have processes and practices in place to wipe out software defects before they enter and have the ability to test them out as we start to deliver software more frequently and more automatically. I've pulled some of this data. This data came out in Teresa Lanowitz's keynote today, too. My numbers are an aggregation of a number of different sources, so that's where you see these bands. So, for example, I was talking about defect prevention or development testing technologies. Static analysis has a penetration rate somewhere between 16 and 28%. Now, I'm probably a little older than most of you in the audience, but let me tell you this. When I was in college and I wrote a term paper, I was allowed to have like 3 to 4, maybe 5 spelling errors in a 10-page paper. I could still get an A. Today, if your children are turning in their term paper and they have 3 to 4 spelling errors in their 10-page paper, they're done. It's an F. You know why? Because static analysis for term papers or spell check can find and prevent these errors from happening. The technology is out there to prevent defects. Static analysis is a fantastic one and has a penetration rate of about 25% on average, which is a little atrocious. So when we look at these types of automated testing practices, we need to do a better job of involving these things into an automated process in order to not only prevent software defects, but also automate the testing process throughout the life cycle. And this is what we call continuous testing. Staged, policy-driven testing that isolates errors in certain stages of the SDLC and giving managers better information about the quality of the application continuously so you can make better trade-off decisions. And this is what it's all about. At the end of the day, we need to prevent and eliminate risks. The more risks we can prevent, or the better information that we can give our business managers to make these trade-off decisions, the better job we're doing as testers. Part of what we need to do is also open up a test environment. Using simulation to open up a test environment is what's in the red box on the bottom here, also called service virtualization, is what I'm going to continue to talk about now. So service virtualization delivers a simulated test environments to help developers and testers with earlier, faster, more complete testing. I love it because service virtualization is a great buzzword these days, but I have to tell you that our friends over in the embedded space have been using emulation technology for decades. We're catching up. From a software perspective, service virtualization, which provides a simulated test environment, is the equivalent to the emulators that our embedded testers have been working with for years. Using this technology really gives us the ability to do much more earlier in the cycle. So whether your target application or your application under test is faced with third-party systems that you can't get access to, or perhaps you have a parallel development effort and there's simultaneously evolving components, or perhaps you have to schedule access to a test environment in order to get your test done. We really face a number of different constraints in terms of bringing a test environment up. This idea of simulation and leveraging simulation gives us the opportunity to really test earlier. So the use cases we usually see that promote this idea of leveraging simulated test environments are folks who are using more agile or parallel development type efforts. So when speed and dealing with incomplete systems is of the essence. In performance testing, simulation is awesome. I mean, we've been using virtual users for years in order to press load against an application. Since you're trying to actually performance test that application anyways, using simulation technology from the back end to actually give you more complete view of how the application is going to perform makes total sense. For mobile application development, we're seeing the need for service virtualization really blossom. And this is because when you're evolving your mobile application, you don't necessarily have control over the telco network layer. You're basically in the wild when it comes to that. Service virtualization can actually simulate that telco network layer, giving you more realistic test runs in the lab. And then finally, if you're trying to do much broader end-to-end functional testing, the need to actually connect that application under test with all the various dependencies is critical. In Teresa Lanowitz's keynote, she had mentioned that the average number of dependent applications connected to or associated to the application under test was about 33. Am I right, Teresa? 33. We did a survey. Ours came in at 30. So we're in the right ballpark, so we're fact-checking here. So 30 dependencies. And when you think about 30 dependencies, you really want to get access to the most realistic environment possible. And this is where this concept of service virtualization comes in. So the biggest question I get, and mostly from testers, is, okay, so what are you virtualizing? We're using VMware. We have hypervisor technology in-house. What are you virtualizing? Service virtualization basically creates a simulated transaction at the message layer. So looking at the protocol in which the application is communicating to the other dependent application, maybe it's a web service, maybe it's a REST-based transaction, maybe it's an MQ, maybe it's something through the native SAP XIPI type environment, or maybe it's a KIX transaction back to your mainframe or back end. What we're doing is we're watching the communication channel from the application under test over that protocol, and then capturing the message payload, and then simulating this. This is where service virtualization comes in really handy. Basically simulating the transaction over the message layer. Okay, the next question I get, Wayne, this is a stub. You're right, it is. It's a stub. It's a mock. It is a stub or a mock on steroids, though. So instead of the brittle case in which that stub is created and then put onto the developer's desktop or hidden somewhere that it's not reused, or the case in which it provides a pretty limited static response, what we have done is take this concept of a mock and place it into an environment in which you can now control the behavior, the performance, and the logic of that stub in conjunction with your broader set of dependencies. It's a nice little place for it to live and be reusable. So we mentioned before that the primary need for service virtualization really resides in some of these areas. So, for example, parallel development delays, creates delays for developers, meaning that they're trying to roll a parallel component. The developer is waiting for team B to actually finish what they need to do in order to exercise what they've just created. They need a simple, realistic access to the dependent components in order to complete their test, or even unit test. So they feel trapped. Service virtualization plays here. For the testers, they spend really too much time waiting for environment access. And also, there's a huge need for them to get access to realistic test data. For the performance testers, what they really need is a realistic test environment, the most realistic test environment in order to exercise their application. And with this, though, they're faced with scheduling constraints, the need to configure massive systems, or time limits in terms of access. So in a separate survey that Parasoft did, we found that over 80% of testers were actually limited in the amount of time that they were actually given access to the test lab. That basically totally curtails the amount of testing you can do. So how do you actually eliminate those barriers? Well, what we did with service virtualization is take the fact that these dependencies are independent transactions associated with your application under test. So maybe it's a staged asset. Maybe it's a dependent application. Maybe it's a virtual environment in which you're using VMware or some hypervisor technology to emulate it. We broke that apart. And then we give you direct access to it via simulating the interaction to that component. We do this by observing the transaction, collecting the transaction, and then giving you control over it. I'm going to go into a little more detail around how that happens. However, before I do that, let me take a little sidestep. You heard from Voke Inc. today, and there's basically two analyst firms out there that are covering service virtualization. Voke takes a pretty unique look at it. They were not only the first to look at service virtualization, but they were also the first to look at lifecycle virtualization and its need for the development and testing environment. So they have a tremendous amount of research already built up. If you go to their website, you can sign in. They give you great access. You can ask questions and create that connection with Voke. They were the first person, actually, first real analyst firm to produce any kind of survey around service virtualization. With permission from Teresa, here's some sample of what they've collected. Service virtualization improvements, basically the respondents said average test coverage increased by 87%, average provisioning time reduced by 80%, average time to market improvements by 35%, which is pretty significant. Average test time availability increased by 48%. Forrester is also started just this year, in fact. Voke's research has been going on for at least the last 5. Forrester introduced another segment with service virtualization this year, and basically this is a little bit of what they are saying about the technology. Quality, less production defects, basically a better environment, allowing you to actually test things out. Cost reduction and speed. Their survey was a little bit different, but the reason for adoption was better test coverage, reduction of wait times, the better availability of services, the ability to reduce production defects, and then time to market. Those were the reasons for adopting service virtualization. They came at the questions a little bit differently. But two good resources. If you go to Voke's website, you can get at some great details around it. So there's a lot of confusion at times about when to use service virtualization and what to virtualize, and when is it a good technology to entertain and when not. So I like to think about it in really two axes. The first one being configuration. So in order for you to actually test something, you have to have what I like to call geopolitical control of the application, which means that not only do you have permission to access it, you have permission to configure it, and you have permission to manipulate the database behind it. So on this array, there are simple things to connect to, and there's complex things to connect to. Then there's test access. So do you actually have control over it? And then again, you have simple things that you can get access to pretty immediately, and you have things that you don't get access to very, very well. And along this whole array is where you start looking at things that I might want to use service virtualization for. So let's take an internal service or an internal application that your team has pretty good connection to. You know, it's under our control. We know about it. We can use VMware to connect it. We get pretty good access to it. You know, maybe using simulation technology with this application is not necessary. You get into this other band, though. And this band is, you know, maybe internal databases, web services that are web servers that are not your own, ESBs, enterprise service buses that can be very complex, message queues, and maybe cloud-based applications in which there is a fee to access, or you don't have direct control over it. So configuring it is really a problem. This is the area in which service virtualization starts to make a lot of sense to access, meaning that simulating the transaction can eliminate the wait time or the time or complexity to configure that application in order for you to begin testing. And then you get into this outer band where it really makes sense. Maybe it's a mainframe application, an external complex database, or an external application you have no control over, or maybe it's the ERP or the SAP financial system, which quite honestly, they don't want you to mess around with too much in a test environment. But creating a simulated transaction can allow you to execute your end-to-end tests with really 0 degree of risk. So let's talk about risks just a second. With service virtualization, you have the ability to create a risk-free test environment. And what I mean by this is you're creating something fake. It's a stub. It's going to respond how you program it to respond. It's going to respond with data that you put into it. You can't get anywhere behind it. It's fake. The risk associated with actually accessing this is limited. If you're testing with partners, with a group overseas, if you need to open up a test environment to third parties, this is a fantastic way to do it, totally eliminating security or privacy data issues associated with accessing your data. It's a great technology in regards to that. Let's talk about service virtualization in combination now with another technology, which may be virtual lab or virtual servers. So there's a lot of confusion between what service virtualization is and what hypervisor technology or server virtualization is. In this simple graph, we're using the same things around configuration and access as the axes. And what you want to think about here is, if you have geopolitical control of that application, and you know your way around it, and it's the most realistic environment you can build, go for it. You don't need service virtualization. If you have access, you know how to configure, and you're confident that you can get access to it when you need it, there's no need to simulate that interaction. For everything else, service virtualization. Let me add a caveat here. You want to use simulation technology early in the cycle when things are changing. But as you start to progress towards release, you want to get yourself into the most realistic test environment possible. And the need or the value of simulation reduces a bit. Now, there's a caveat to that, and the caveat to that is, if you don't have access anyways, simulation is a great alternative. But it shouldn't replace the most realistic, manageable test environment that you can get your hands on. It's very complementary. So how does service virtualization work? So the first thing we do is there's a couple different ways for this to work. There's a passive model and there's an active model. In the active approach, there's proxy technology, which is installed to collect the transaction of the dependent system. And this is where we monitor the transaction. So basically, a proxy is set between the application under test and the dependent application. We basically observe transactions, sit there and observe transactions. While we're doing this, we're doing a couple things. We're understanding the message payload and how it changes, and we're collecting request-response pairs. I can never say request-response for some reason. I get tongue-tied. I'm glad I did it. So you're collecting these two request-response pairs. Basically, at that point, we're building test data for you. Now, what we've done is we've understood the model or the shape of the transaction. So we see the protocol because we're now sitting on the wire, and now we're collecting and understanding the logic associated with the transaction that's happening over time. With this observation now, this virtualized asset, which has already been created for you, is now able for you to actually model, construct logic around it, import data. You can also program the performance of how you would like it to respond. And we deploy it back into a virtual environment where it's now provisionable and can be consumed by anybody who's accessing that particular environment. Let me do it in pictures real quick. So the first thing we'll do is we'll tell QA or test to basically deploy these monitors or these proxies. Then you'll fire off some tests. And when you fire off some tests, we're basically learning, right? We're collecting that information through the proxies and creating service virtualization assets. We're learning how that transaction works. We then collect the traffic logs and pull it into a central environment, which is our Parasoft virtualized environment, in order for you to actually create and evolve how you want that particular service virtualization asset to behave. Then we push that over to the virtualized server, where it's now deployable. And at this point, you can go through the environment manager and basically redirect all that traffic that was going to those staged systems or the dependent systems into the virtualized server, which is going to give you a simulated response, basically allowing you to test with ease. So another way to think about service virtualization is really about the cost of access. Today, you have the option of creating a staged application instance or a staged environment. Very costly, both with CapEx and OpEx, but a very costly option. With virtual lab management, we can reduce the costs here, and there's two sides to that. You can reduce the costs with hardware savings because you're using server virtualization in order to actually create new images of that application on a single box. And you get this access efficiency because most of the people who are providing hypervisors or even cloud-based environments like SkyTab gives you the ability to actually promote images more rapidly that are configured to your specifications. So there's this configuration acceleration that happens when you're using sophisticated lab management tools. But here's where service virtualization comes in. In those two previous instances, you have to have control over the application. You got to know how to configure it, and you deploy it. With service virtualization, we don't mess with the application. We mess with the transaction layer. So you lower your costs dramatically associated with configuring the application for your test environment. So we did a survey that I mentioned previously, and essentially we asked this question. Of your dependent applications, let's say that there were 10 APIs or 10 services, what percentage of those APIs do you need access to in order to test? The answer came in at 20%. So basically what we're doing in most cases in terms of standing up a dependent application is building an entire application only to test or only to need access to 20% of it. Service virtualization solves this problem. It allows you to actually only configure and stand up the portion of that dependent application that you need access to. And it lowers your time and cost considerably, which is particularly this area of the curve. So value points here, service virtualization allows you to manage only the components you need. Service virtualization does this in a simulated environment, which pretty much presents a low-cost alternative to actually standing up and configuring an entire application. Additionally, this is disposable. It's risk-free. Nothing's behind it. You can't have a breach through a stub. So from a security and privacy perspective, it's a much, much lower risk. So I'm going to go through 3 more slides, and then if you have any questions, why don't we do that for our final 10 minutes. So there are a few value drivers and ROI drivers associated with service virtualization. So first is the human driver. So definitely a reduced operation expense associated with actually managing the test lab once you have your simulated environment stood up. Another key to service virtualization, which is very interesting, is that you give QA and testers the ability to truly understand the environment complexity. In many cases, when we go and stand up a service virtualization environment, it is the first time a tester has true exposure to the system dependencies associated with their application under test. So within the environment manager, they're actually presented with the entire dependent system that actually hits their application under test. And it's usually the first time they've seen this. Operational efficiency, which is a big one. So this is really the biggest one. We can truly eliminate delays associated with system configuration, data management, performance configuration, and mostly setup and teardown of that test environment itself. You can have a simulated test environment in front of you in order to test anytime and anywhere. So on the physical side, you can reduce CapEx in terms of server sprawl or in terms of actually setting up an additional stage test environment. Basically, you're only going to reduce the incremental need for more capacity with service virtualization because no matter what, service virtualization is a complementary technology that uses simulation. So you can't really get rid of that most realistic stage test environment that you need. But it is going to reduce the fact that you need to expand that stage test environment. And some people say you can eliminate physical test labs, and I would say very, very careful if you bought into that. Project and process value. Time to market. Even though in most surveys people have said that service virtualization actually gives you a reduced time to market, I'd be careful here. In most cases, with my experience of people using service virtualization, the most immediate next step that you're going to realize by using this technology is, you know what? I can now test what I've been putting off for a long, long time. So instead of really speeding that release and basically getting that advantage of time to market, what you're actually going to want to do is focus on reduced risk. Expand your test cases to actually test those corner cases or do more exploratory testing, to do the things that you wish you could do that you're not doing today. Access anytime, anywhere is a huge issue here. The other very good benefit here is actually defect reproduction. So with service virtualization, you not only can actually look and capture a defect, but you can ship a test environment with it to show you how that defect was actually produced. Very, very valuable as you go through that iterative loop of, well, I can't reproduce it. You can actually ship them the environment in order to reproduce it. One note here, we've published a book that you can get free online. It's called Continuous Testing. Part of the continuous testing book actually goes into service virtualization and the value of service virtualization. And if you go to this URL, which is alm.parasoft.com, and then a single word, continuous testing book, you can get this book for free. We'll in PDF form. So feel free to get there. You can also go to the Parasoft website and go /resources, and I have that URL coming up. I see people furiously writing, so I will stall a bit. So it's continuous testing book. A lot of my presentation that I just went through is encapsulated here, as long with some other details. So with that, if you have any questions, I'd love to hear them. Yes, sir.
How does it work on maintaining the service? So say you do your you get all your services locked out, and now the application under test actually is also changing some of the services.
Yep.
How do those, and the services aren't developed yet, so there isn't anything to record, but you might have a definition of the contract. Is there a manual way to mark that?
Yeah, so the question is, how do I maintain a simulated test environment if I'm using service virtualization, if the application under test or the APIs are actually evolving with that application under test, correct? So there's a couple ways to do this. So what we do is we basically actually create a little regression suite around the API itself and give you the ability to adjust business rules to the sensitivity of change. We call this Change Advisor. So essentially what we do is we monitor that API for you, and if there is a material change as you define, let's say there's a payload change, maybe somebody versioned it out and added an operation or eliminated a data element in an operation, for example, we can give you notification that there is a material change associated with that endpoint, and it will pop up in the environment manager. We also have a social media type of follow paradigm within our platform, meaning that let's say there's 2 or 3 or 5 APIs that you're very concerned with, you can subscribe to them. And if you do get a change notification, you'll be alerted to the fact that there's been a material change in the API. So that's one way we just alert it. The second way we do this is there's a series of business rules that you can invoke on the way you would like change to be handled. So let's say you're actually hitting, for example, the FedEx API for shipping and tracking. You might not have any ultimate control over that, so you might want that endpoint or that virtualized asset just to version itself up automatically. You can do that. I would not recommend that for all services at all. There's a lot more sensitivity because you might want to really understand the impact to the test suite in terms of that changing API. So there's a number of granular steps that you can take that alert you to the change, show you the change and the impact of the test suite itself, and then ultimately give you advice on how to rev up that particular endpoint. So we do that by monitoring. Did I answer your question? Thank you very much for the question.
Okay, Wayne, we have a couple questions here from Virtual World. The first question is, if possible, how can we benefit from service virtualization to do browser compatibility testing?
From browser compatibility testing. You know, I would say totally different, separate technology. And let me think about that, and if I can get the address, I'll respond.
Okay. And the next question is, at what point should you realize that service virtualization or server virtualization is either getting too expensive or too large and complicated?
That's a great point. So you'll know it when you're unable to test. So if you're at the point, when you're using server hypervisor technology, server virtualization, let's make one point very, very clear, and I've said it a couple times today. You need really granular knowledge and control over the application itself. So if you're at a point, even using server virtualization or things like VMware or hypervisor technology, and you can't get access to those other dependencies that are basically constrained from you because they're basically the geopolitical relationship between your team and someone else's team, or your organization and a third-party organization, that's when you start looking at simulation technology as a complement to that type of server virtualization technology. And let me just state it, because we're coming to the end of the time here. And it's the one thing that you should really keep in mind around service virtualization, is if you can get access to the most realistic test environment ubiquitously all the time, there's no need for you to simulate. But when you can't, service virtualization is a key to augment that environment. And that's a really key point as you start looking at this. Any other online questions?
Yes, we have time for one more question. What would we do if there is no staging environment for the virtual service to capture? Would the concept of virtual service still be viable and achievable?
Absolutely. So in that case, you have a couple different options. First of all, it must be accessible some way, somehow, some method, right? And if it's not the case where you don't have a staged test environment, it means you're making a call out of your application under test to something. So you understand the protocol, and you can observe the message format coming back. So there's a couple ways to handle this. You can actually fire a test case at it, and we can observe what's coming back and then start building a virtualized asset based on that payload that we observe. Or you can model it from scratch. So since you understand what the protocol is itself, we can actually build the payload in a model and turn that into a service virtualization asset that gives you the same value over time. Great question. Well, folks, we have 29 seconds left here, which means that I'm on time, and I appreciate that the fact that there was standing room only here. So thank you very much for coming.